Okay, recall that I said this whole chapter is about the C preprocessor, and the C preprocessor is about text substitution. You've already seen one type of text substitution, the substitution of one line for an entire file via the hash include directive. Well, now we look at another type of text substitution, the hash define directive. It's used to replace one text string with another, or one identifier with a sequence of code. Let's have a look at that. Hash define max 30. Okay, now what does that possibly mean? What it means is replace all occurrences of the word max exactly like that. Case is dependent, so it's not uppercase, lowercase, it has to be exactly the same in the rest of the source code with the number 30. So if you like, it's a simple search and replace. It happens from the line where the hash define is all the way to the end of the file, and that's all that it does. You might think, okay, well that's pretty simple. It also sounds pretty useless. Why would anybody need that? Why would you ever need to replace one thing with another? If you wanted the 30, why didn't you just put the 30 rather than put max there? It's a fair question. Why would you need that? Anyway, let's just have a little bit of a more detailed look at it before we answer that question. It helps us with this particular rule of code. There should never be any magic numbers in a piece of source code. This is not a rule. This is just a guideline. This is just if you want to write quality code, if you don't want to be thought of as a hack who doesn't really know how to write code, then you tend to follow this rule. And this rule can be said in a slightly different way. Look through your code. Look through any piece of C code that you have. Look through all the, say, 50 lines in that particular file. Look for any numbers. Look for the number 100, or look for the number 25, or look for 7.18291, or anything. Well, the numbers 0 and the number 1 are somewhat clever, so don't really worry about those. They don't really count as magic numbers. But numbers that are like, if you ever said to yourself, alright, the length of my string is going to be 40 characters plus a null, so it's going to be 41. I would go so far as to say that 41 is a magic number. And this rule says there should never be any magic numbers in a piece of source code. Alright, so you take it out. How do you take it out? Well, instead of saying 41 inside the square brackets in your string declaration, you might say something like max length plus 1. And max length could be a hash define. You could have a hash define somewhere that said max length is 40, not equals 40, because there's no equal sign. Notice there's no equal sign in the hash define. You just have hash define max length 40, and then that would be up the top of the file, outside of the main, way up almost near where the hash include lines are. And then down in your file you would say your declaration of your string inside the square brackets, instead of the word 41 or the number 41, you would have max length plus 1, and thus you have removed the magic number of 41 from your code. That's how it works. And again, in a very short amount of time we're going to have a talk about why that's important, why you should never have magic numbers in your code. Okay, before I do, just note that you don't have a semicolon on the end of this line. There's no semicolon after the word 30. In fact, there's no semicolon on the end of any line that begins with a hash. Any line. Because it's not really a C statement. It's part of the C preprocessor, and the C preprocessor doesn't care about things like that. It doesn't have anything to do with the semicolons on the end of regular lines. It can't be thought of as a regular line of code. It's a special line of code that has to do with the C preprocessor. Anyway, the answer as to why you use these hash defines. Hash defines are critically important. If I was to look at some piece of commercial code of several thousand lines of code and it didn't have any hash defines in it, I'd just throw it away. I'd say, just don't give me this rubbish. Come back and bring me the source code rewritten with the right amount of hash defines in it. And there's a twofold answer as to why that would be considered to be rubbish. The first is readability. Consider the following line of code. Okay, now there's nothing unreadable about that. It's certainly pretty clear. You can see what's going on. Multiply x by 3.76 and see if the result is greater than 259.6. Okay, fine. But you, the programmer, reading through a piece of source code and you encounter that line, you think, alright, I can see what he's doing here, but why is he doing it? what is he actually trying to achieve here? Now, if instead you didn't see that, you actually saw if x times commission is greater than maximum, you go, okay, that's clear now. He's simply multiplying that number by the commission and seeing if the result is greater than, say, the maximum commission. Hopefully you can see that that second line is far more readable than the first line. And of course you can figure out how to get the words commission and maximum in there. You can simply do a hash define commission 3.76 and hash define maximum 259.6 if those numbers were constant. Obviously the commission and the maximum here must be constant throughout the entire duration of the program. In other words, they can't be variables. If commission changed from one moment to the next inside the program, then commission could not be a hash define. It could not be a constant. Hash defines always define things that are constant. In other words, it would have to be a variable, and the same applies to maximum. Maximum would have to be always 259.6. If it was not going to be 259.6 for the entire duration of the program from start to finish, then you would make it a variable. Now, if today it's 259.6, but tomorrow in version 3.6 of the code it's actually gone up to 270, then you might want to simply change the hash define and recompile the program. Think about that. If you recompile the program, then the word maximum will have a different value substituted for it. So can you see why hash defines, well, this is one of the reasons why hash defines are so important. If you've got two hash defines, one of commission to be 3.76 and one of maximum to be 259.6, what actually happens here is that as the preprocessor processes the .c file, it does essentially a search and replace. And commission, the word commission is replaced by 3.76 and the word maximum is replaced by 259.6. And then the compiler kicks in and actually compiles the file. That search and replace, that actual substitution, is only temporary. It's only like for the duration of the compilation. When you actually go and open up your file again, you'll find it still reads commission and maximum. It won't read 3.76 and 259.6. The second reason, probably an even more important reason than the readability reason, is maintainability. If one of these constants, if one of these hash defines changes, in other words, commission is now no longer 3.76, now it's 4.12, then what you don't have to do anymore is you don't have to go through your entire program searching for 3.76 and changing it to 4.12. You don't have to do that, because you'll know that there's just going to be one definition of 3.76 right up the top of the program at where the hash defines are. You can just simply go up to the top of the program, change the 3.76 to 4.12, just make one single change, recompile the whole program, and your program will now be working with the different value. So you only have to do it once. You don't have to do a search and replace. And you might think to yourself, well, so what? You know, search and replaces are quite easy to do. My editor program is quite capable of doing a global search and replace. I can just search for 376 and replace it with 4.12 and my problem solved. It only takes me a couple of seconds. Yes, that is true. But what if you had another 3.76 in your program that had nothing to do with the commission? What if the 3.76 was the exchange rate for the day from Deutschmarks into dollars or something like that? And you inadvertently changed that from 3.76 to 4.12. You've actually broken your program then, because you didn't realize that there was a 3.76 in your program that didn't have anything to do with commission. Moreover, what if you had a 3.76 or several 3.76s in 100 different files? You'd have to open up 100 files and do 100 lots of searches and replaces. Now, of course, in this particular example, you wouldn't have a hash define of commission equals 3.76 up the top of each of those 100 files. You would take the hash define out of each of those 100 files. In fact, you wouldn't even put it in there in the first place. Where you would put it would be in a hash include file. You'd put it in a header file, and you'd simply include that header file in all those 100 files. Can you see how that will help you? You might have 3,000 different occurrences of 3.76 in your entire system. However, if it changes from 3.76 to 4.12 one day, all you have to do is open up the header file, change to 3.76 to 4.12, recompile all the different C files, in other words just run the whatever script or makefile that you're using that recompiles all your 100 files, and your entire program has been converted to use the new value. So that can be summarized by the last bullet point here. Hash defines that are used in more than one .c file should, well, they really must be moved into a .h file. So if you find that you've got a 3.76 definition for commission in one file and you've got another hash define line exactly the same in a second .c file, then simply remove it from both files, remove it from both .c files and put it in a .h file. If you need to, create a .h file. Okay, it's probably now time to go and have a look at some concrete examples of that. This is define.c, which I'm going to use to demonstrate hash defines for you. Now, if you recall, this is simply our program that prints out the grid of the 18 by 18 times table. Remember that? Okay. Now remember also, I just said to you a moment ago that we don't want to have any magic numbers in our file anywhere. Now, do we have some magic numbers? Yes, of course we do. Can you see them? Yes. We have 18. 18 is our magic number. Well, we also have a 0 and a 1, but I don't really care about those. As I said, zeros and ones aren't really important. Obviously we're going to start with 0, and obviously we're going to go up by 1 every time. Okay, so all I really care about is this 18. So what I'm going to do instead is I'm going to create a hash define that reads hash define grid size to be 18. Okay, that's going to essentially be how big our definition of our grid is. Now, before I go through and make all the modifications necessary, I want you to think about this in your head. If I said to you, okay, I don't want a program that does the 18 times tables now I want a program that does the 21 times tables, or say the 15 times tables, how many changes would you need to make? You had to go through and count them, didn't you? It's 1, 2, 3, 4, 5, 6. You had to make 6 changes. Now the point is, you have to think about how many changes you have to make, and then you have to make 6 changes. It's interesting. I want you to keep that in mind. I'm going to go through and make those 6 changes right now, but I'm not going to be changing 18 to 21 or 18 to 15. I'm going to be changing 18 to grid size, and we'll have a look at that. Okay, finished. So you can see what I've got now. Instead of the words 18, I had grid size here, and here, and here, and here, and here. I think you'll agree that the program is slightly more readable, because in here you come along and go, okay, I'm looping up until I get to the size of the grid. That 18 was something of a mystical, magical number. You go, oh, I can see that you're looping 18 times, but I don't know why 18, and why should it be 18 and not 27 or 3000 or 1? Now it's quite clear why it happens to be 18, because that is the size of the grid. Okay, so it is slightly more readable, at least it is in my book. Furthermore, if I wanted to make this now a 15 times table, all I need to do is that. Recompile the program and it's done. 21 times tables. Okay, it's done. I need to change it once. I don't even need to think about how many times I need to change that throughout the code. I know that the answer is always once, assuming that the code has been written properly and I don't have some stray little 18 sitting down here, which would be very naughty. Assuming that I don't have that, then I only ever need to change one line of code, no matter how big I want to make my grid. Let's put it back to 15 and see if it actually works. Okay, 15, compile, no errors, run, 15. So it goes to 15, it goes to 15 there. Let's make it 16, just to prove how quickly and how easily we can change this program now. Compile and run, and now it goes to 16. I think everyone will have to agree it is now much, much easier to change the definition of our program. Okay, what I'm going to do now is I'm going to go back to the previous example, the include file example. Remember that one just a moment ago where I included string.h and stdio.h? Okay, I'll just bring that file up onto the screen. Now are there any magic numbers in this program? Yes, there is. There's one just here. What does this 41 represent? Well, it represents that we can have a maximum length of a name of 40 characters, plus 1 for the null. So how would I rewrite this so there are no magic numbers in my program? I do this, hash define name size of 40, and then I would go change this to name size plus 1. And that's perfectly legal to do that, by the way. You can have name size plus 1 inside the square brackets because this will always evaluate to 41. It has to. This is not a variable, this is a constant. Let's just check that that compiles. Yes, no errors, and I'm sure you can probably imagine that it's going to run exactly like it did before. Okay, now I want to take that one step further. Let's say I had a vast program that contained many .c files, let's say a dozen .c files, and they all needed to know that the maximum size that a name could be is 40 characters. So what I would probably want to do is I would probably want to create my own include file and take this definition out of this file and put it in the include file such that all of the .c files could then have access to this particular hash define. And this is how I might do it. Hash include, and I'm going to put it in this particular folder. It's not going to be a system-wide folder. I'm going to put it here, and I'm going to call it maximums.h. So I'll now go and create maximums.h. Okay, here's the nice sample maximum.h. In fact, it hasn't got anything in it whatsoever, but I'm going to put something in it. I'm going to take that line out of include2.c. I'm going to take this line right here, and I'm going to cut that from there, and I'm going to go back to here and paste it. Okay, fair enough. So that's going to be my entire maximums.h, and the other one is going to look like this. You can see that that is going to have the hash define definition in it that is needed here. So let's compile that. Okay, 0 errors. Excellent. Which means, of course, that it's working. It's getting that particular definition out of our header file. If we've got 0 errors, all we need to do here is check that it compiles. Of course it's going to run. It's going to run exactly the same way it did before. The fact that it compiles proves to us that this header file here must be functioning correctly. So that's about it for hash defines and include files. Let's move on now to the next module, which is called macros.